Hi, everyone. Good morning. My name is Mark Dredze. I'm a professor at Johns Hopkins in computer science. I'm also affiliated with the new Data Science and AI Institute, and I do a lot of work with colleagues here in public health and medicine. So my area of research is artificial intelligence. I have been doing this before it was cool, before we called it artificial intelligence, but the name has made a comeback. And so this has been a really exciting time for the field and for what I do, thinking about the implications of the type of work I do and health and medicine. I think in particular, my research is in natural language processing. So this is AI with language data, which has really seen a tremendous amount of excitement in the past couple of years. So the way I used to explain it is people used to ask me, what do you do? I try and explain it to them. They wouldn't really understand. So then I would say, well, do you use like Google Translate? And they'd say like, oh yeah, I know Google Translate. That's great. And do you do that? And I'm like, well, no, I don't do that. But like, I know those people. Uh, and now I walk into a Starbucks and the people in front of me are talking about ChatGPT. I'm like, I do that. So it's really been an exciting time in terms of the quality of the technology and how fast things are moving, but then trying to understand the implications for a lot of the application areas that use this technology. And so what I want to talk about today is how we should think about that in terms of health. So that's really the question. How should we think about using large language models like ChatGPT and Google's Gemini, and there's others? How should we be thinking about these for health and medicine? So the way I'm going to start this is actually I'm going to go back in time about a year and a half before ChatGPT was released. And I gave a talk on this topic. What are the changes that are happening right now in AI, and how are they going to impact medicine? And so I'm going to tell you what I said because I was wrong. And I think it's great for me to just destroy my credibility at the start. In fairness, most of what I said was right, but that's not interesting. So I'm only going to tell you the stuff I said that was wrong. So I'm going to show you some of the slides from that talk. So I said, well, recent years have seen dramatic changes to the field of natural language processing. I guess that was wrong because the changes that we had seen up until that point were nothing compared to what's happened in the past year and a half. And this was at a workshop on building models for clinical data, so specifically clinical text, think medical records. And at the time I said, we really need to think or rethink the future of this field, given all the changes that were happening. That is all the more true today. So some of that was right. And what I said at the time was that we will not have enough computing power or data to train a model like ChatGPT, although that didn't exist, so I called GPT, for clinical data. And even if we could build it and we decided to invest, $5-10 million into building it, we couldn't release it or give it to anyone because of privacy concerns. And so what I was thinking at that time, which was wrong, is that these types of technologies could not be used for clinical data. They could not be used in medicine, and we were going to have to find a different path. At the same time, I was very pessimistic about where the overall field of AI was going. Namely, the types of things that people have started to work on at that point weren't really good fits for the core problems we were thinking about in medicine. So up until recently, I would say most of the effort and energy in terms of AI research in clinical medicine, when you looked at text data, was how do we extract out of that text structured information? So a really typical example, I want to do a study with patients that have this particular disease. And so I need to find in my healthcare system all patients that have been diagnosed with this disease. Unfortunately, it is not coded. And so the only way I would know if someone has this disease is to look at the medical text. And therefore, I need models that can read that medical text and say, does the doctor write that this person has a disease? Those are the types of problems that we're really focused on. But the directions of the field were really going in a different place, dialogue. So how do we build systems that we can converse with? How do we, language generation is how do we build systems that can generate text, right? Create new text paragraphs. And you've seen that in ChatGPT. How do we answer questions about text and from text? These types of things that I just didn't see being core to the few, or they hadn't up until that point been a large part of the focus of AI for clinical text data. At the same time, the types of models that we were seeing at that time, as I said, like GPT, weren't really going to be available for clinical data. So that's kind of where we were at that point. And at the same time, there were some reasons to be hopeful. So there was a study that had just come out using what at that time was GPT-3 that tried it for these types of tasks. So it gave this study out at MIT, gave GPT-3 medical records and asked it to do things like pull out of this medical record a list of the diseases or a list of the procedures or a list of the medications. And I was initially pessimistic because the models that had been trained by OpenAI hadn't seen medical records, right? Medical records are protected. The data that was mostly used to train these models were all downloaded from the internet. So I wouldn't expect to have ever seen a medical record. And so my initial thought was, of course, the model wouldn't do a very good job of these types of tasks and was just not going to be useful to us. And it turned out that that was wrong. And this was a study that was out at the time where they gave it, this is an example of the input, so a snippet of a medical record, and the query, what we would now call a prompt, but back then we weren't yet using that terminology, all the way back in 2022. The directions here are create a bullet list of which medications are mentioned and whether they are active, discontinued, or neither. And the point is, the system did fine. And so it wasn't great. It wasn't as good as the systems we had, but it was really surprising that the systems were able to do this. And so it was a suggestion that maybe these systems had some kinds of medical capabilities that I didn't really understand where they were coming from or the extent of those capabilities. So I was pessimistic, but there were some reasons for optimism, which is good because I'm a super optimistic person. I don't like being pessimistic. The other thing that I noticed was happening is I had said that the big focus in the clinical space in these types of technologies were extracting information from the records. And already there were some studies that were trying to do new things. So this was something that I think now a lot of people almost expect these models to do, medical note generation. So if we give, if a doctor gives the system some basic information about a patient, can a system automatically write the clinical note? And this was a paper that came out in 2022 suggesting that this is something we could do and looking at some of the issues around it. And so I looked at this and said, well, this is something that we wouldn't have tried before. The technology just wasn't good enough to do anything close to this. But maybe we should start trying these things. And so maybe the technologies that are being developed by companies like OpenAI aren't going to be very good at doing the normal things that we do. Maybe I'm wrong, but maybe they're going to be good at doing new things that we haven't done before. Okay, so that's where we were in summer 2022. By the way, the questions are open. If you have questions, just drop them in and I will kind of work them in as I talk. What has happened since then? And I think people here might be more familiar with what's happened since then than before, given how much this type of technology has permeated society in all different sorts of areas. So the most significant thing is OpenAI released a model called ChatGPT. This was, I think, by their own admissions, they did not think it was such a big deal. So the kind of informal story is they were working on these kinds of models internally. They had a model that we call GPT-3 that had come out in 2020. They were actively working on the next version of that, which they call GPT-4, which came out a while later. And they kind of had this side project to take a version of that and make it a little more responsive and a little more user-friendly just to let people interact with it. I don't know if that story is true, but that's kind of the informal version of the story I had. And so ChatGPT was born. And I think it's fair to say the impact far exceeded their expectations. The statistic people like to throw around, it was the fastest app to reach 100 million users in history. I'm not sure that's a fair metric, but it doesn't matter. The point is, like, everyone here has heard of it. So, like, it was pretty popular. But more than that, a lot of different models came out after that. So now there are models all over the place. You might have heard of some of these. There are many, many, many more out now. And what really was interesting in kind of a lesson learned is, I think at the time, we in the community thought of GPT-3 and ChatGPT as a model that very few people would ever be able to replicate because of its cost and size. And that was wrong. And now there are many such models available, both proprietary, open source, academic, and more coming out every day. And that has really shifted the landscape, but also shifted our thinking, because maybe it's not so hard to build these as we thought, and maybe building clinical versions of these models or medical specialized versions of these models is much more realistic. And that's exactly what happened. So you had papers like BioGPT, which was out of Microsoft in late 2022. And this was a version of GPT-3 that's much smaller, but was trained on the biomedical literature so that it could answer questions about medicine. You had a collaboration between Stanford and a company called Mosaic that has later since been acquired, where they built a much smaller model, but they trained it just on PubMed. And so the idea was just to build a model that could answer biomedical questions. There were two different projects. I'm just showing the MIT one here to build another type of model called T5 on medical data. And this was also something that was done by a university. So it was done at an interesting, that we could scale it in that way. And then Google released Palm. Palm became Bard, which became Gemini. They're different versions, but it's all kind of the same sort of model. And they did some experiments to release a model they called MedPalm. It's not publicly available, but MedPalm was, what was interesting about it is it was not a model designed to be used for medical applications. It was their regular model tuned for medical applications. So this really, I think, tested my theory of whether or not these large models that companies like OpenAI were using could be used for medicine. This was an effort by Google that was substantial, but really took an existing model and adapted it for the medical setting. And the results were really impressive. So this is a type of question that they gave the model. This is a USMLE question, for those of you familiar with it. I don't know the answer. But basically, these are the types of questions you get on a board exam. I think this is probably a step 2 question where you're given a clinical case, and then you're asked to come up with I think this is not a diagnosis question, but you're asked to make some clinical decision. And what was really surprising, to me at least, is how well MedPalm did on this. So some of the other models there were models developed specifically for the biomedical setting. MedPalm, again, was a Google model developed on web data and then adapted later to medical setting, and it was already doing better than all of those. It's 67% accuracy at answering these questions. They claim that the passing rate is 60%. Fine, I don't have any specific comment on that. But then only a couple months later, they released an update of this model that was getting 85%. And so to me, this was really astonishing that we are able to take these models that I was skeptical of would be useful, and they're able to answer somewhat challenging medical questions with a surprising degree of accuracy. And I think that was a real surprising revelation to me and really changed my thinking about what was possible here. So that's fine. I was wrong about a bunch of things, but it's fine to admit you're wrong, which is what I'm doing here, and it's being recorded. The question is, what did we learn from that experience? So I think I learned a couple things. So first of all, I learned that the models we have are much more capable than I realized at doing medical types of tasks. And I want to be careful here. there's two different things that I'm a little bit conflating here. One is answering, or actually more than two things. One is answering biomedical questions. And biomedical questions can be answered by models that have read a lot of web text or journal articles, right? A lot of basic facts about medicine, about human biology. Those are freely available on the internet. And so it shouldn't be a surprise that these types of models can do well. For example, on step one questions, right? But then there's medical, or I would say clinical questions, like the one I showed you, that required some knowledge of clinical medicine. And again, I guess it's not surprising in retrospect that the models are able to do well on that, because I'm sure they've seen lots of study guides online. I'm sure they've seen medical textbooks. And so they do have access to the information. It remains to be seen whether or not that's a useful thing in clinical care, and I'll talk about that in a minute, but answering these types of questions, I guess, now makes sense to me. There is another level, which is looking at clinical data, namely clinical text data, and being able to do things with it and say things about it. And there also, the models do show surprising aptitude, and I don't really fully understand why. So what is the kind of data these models are being trained on where they're able to do well at these tasks? And I don't have an answer to that question. So there was one lesson I learned. I think the other lesson I learned is you can actually build models that are pretty good much more cost effectively than I thought. So to give you a sense, GPT-3 probably cost, I'm trying to remember the number. I want to throw out a number between 10 and $20 million of compute time. So that really is well beyond what people can afford unless you're in a pretty well-resourced industry setting. But it turns out you can build pretty good models for much, much cheaper. And they might not be as good as ChatGPT, but they might be good at certain tasks. And that was, I think, a little bit surprising, is we've kind of figured out how to do this in a really cost-effective way for some cases. And the last thing I think we've learned is that while it's impressive that ChatGPT does really well at kind of whatever you throw at it, and the same with GPT-4 and Gemini, if you do have some data that reflects what you want to do, you don't need a lot of it for the model to get much better at it. And so if you want to teach the model how to answer medical questions, it doesn't take a lot of examples for the model to kind of figure out how to answer those questions. So that's kind of where we are now. But if we're going to take this seriously, and we're going to say, okay, well, these models can be useful in medical care, I think we need to start asking, well, what does that mean, right? And let's start with the basics, which is, are these models actually good at medicine, right? So I would say that doing well on a medical question answer data set or an exam, it doesn't mean that this model is going to be a good doctor. And I think this is something people conflate all the time. When we train medical students, we train them by teaching them about medicine, and then we test them with these board exams. And it's not unreasonable to say, for example, that if a medical student knows a lot about different diseases, then they would probably make a good doctor. But the internet knows a lot about different diseases, and the internet is not a good doctor, right? So we have to think about different standards. And if we look at what it takes to answer these kinds of medical questions, it's actually, I would say, not surprising that these types of models do a really good job, right? So what you need to do to answer USMLE questions is you need to understand what are the important aspects of the question, which I think the models do a good job at. You need to identify underlying relevant medical information. These models are excellent because they're really good at retrieving medical information or retrieving any information because they've read the internet, right? And then applying that retrieved information. Those are things that are often really challenging for people. And so if people are good at that, that's a really interesting, I mean, that's a good sign. They're not challenging for computers. And so we need to be thinking more carefully, how are we evaluating machines to decide if they're going to be good in clinical care? So I would postulate instead that what we need for models to be useful in clinical care is we need them to help with the hard cases. No one is going to ask, I don't think doctors struggle with step 2 questions when they're actually practicing medicine, right? those are questions they know the answers to. They struggle with more complex cases. So how are these models going to handle more complex cases? And what makes them complex is that clinical presentations don't match what we've learned about in textbooks, right? If the patient presented with exactly the symptoms that the textbook says, the doctor can probably figure that out. What's hard is where there's a deviation. How well can models actually do at that task? Because they don't have clinical experience. They are just reading the textbooks. So there was a really interesting study done in the New England Journal of Medicine, where what they did is they looked at case challenges. And so if you're not familiar with it, these are kind of interesting and challenging clinical cases that clinicians write in and describe. And they're framed as multiple choice questions. So at the end of the clinical case, you're asked a question and you're given options, and you have to figure out what the right one is, right? It's like a little game. And what was interesting here is they took 38 of those questions and gave it to GPT-4, but they also looked at what doctors' answers were submitted online, because they had access to what was actually submitted by doctors online. And the histogram here shows the average number of right answers that doctors provided. And then the red line is what GPT-4 did. So this was really interesting to me, because this said that GPT-4 got more questions right than not only the average doctor, but the very top doctors. Now, there's a lot of issues with this study. So one is 38 is not a very big number. Being able to do well on 38 questions doesn't mean that you cover the range of medicine. Two is these are from all medical specialties, and there's no doctor who does well at questions from all medical specialties. So I don't know if this model is doing better than the best radiologists or the best GI doctors. It says they're doing better than the a doctor at trying to handle all different types of medical questions. But I do think it's an interesting direction to go in to try and frame models in this way and have them evaluate these more challenging cases. So my group has been doing research along these lines. And so what we've done is we've developed our own data sets where we are building a data set of the same types of questions from JAMA, but here we have on the order of 1,000, I think 1,000-ish, not 38, so many, many more. And we also are building a data set from MedBullets, which is essentially step 2 and 3 practice questions. So we built this for a variety of reasons, one of which is we thought it would be a harder data set, and so it would be a better way to evaluate how the models were doing. So I'm just going to point out a couple things here. So the numbers I want you to look at are the last row here, the JAMA data set. And you can see that models do differently on this data set. So first of all, 67% accuracy for GPT-4, which is kind of the best model out there that we evaluated for this. That is significantly lower than the 87% number I threw out for the USMLE questions. At the same time, it's actually still really good, right? These are multiple choice questions that have 4 answers. I don't have a good sense of like what a strong baseline here is. Random guessing is 25%. I've talked to doctors and some of them have told me like, yeah, but you can usually eliminate 2 of the options, so it's not really random. I don't know, but 67% to me was surprisingly high. But also, if you look across that row, different models do differently. So the first column is ChatGPT. You can see there's a really big difference in quality between ChatGPT and GPT-4. The third column was kind of the previous Google model that does much worse. We haven't looked at the newer ones. Okay, so what I'm kind of pushing us towards here is thinking more critically about how we should be evaluating the ability of models in medicine. And we should be thinking more about the cases, not just, well, are they good at board exams, but are they able to handle cases where we actually think doctors will want their assistance? And for that, we're looking at these kind of more challenging clinical cases that have presentations that really differ from what you'd expect, and maybe they're harder for doctors. Okay, so let me pause here for a moment. I'm going to address some of the questions before I pivot to the next topic. I'm not gonna get to all of them because some of them do fit in later in the talk, but let me pull out a couple that might be relevant here. So one of these is asking if the models are better or worse at different types of questions or different types of medical specialties. So there is variance, and it's hard for me to say, and actually there's a paper online where we have, I think, across something like 20 medical specialties, how well the models do in each one on the JAMA data set, and maybe the med bullets too. It's very hard to give definitive answers. So I'll tell you why. So one is it's hard to say if the questions are equally challenging in each domain. One of the artificial aspects of this data set is they write it up for you so that you can get the answer, right? So if you know what you need to know and you read the article, you should be able to figure out the right answer. Now, it's very hard, right? But you have the information you need to have. Different areas of medicine, that is more or less likely to be true, right? So oftentimes a reason that a case is hard is because we're missing information, like we don't know something, or there's a test we need to order or something like that. So it's hard to say in this kind of artificial setting how that change is going to break down by specialty. Another really important point here is non-text data. So everything we're doing here is evaluating the models on just the text written up. But for a lot of these, we also have images or test data, and we did not give that to the model. So you'd expect, for example, radiology questions, the model struggled at because it couldn't see the imaging data. At the same time, these articles often describe what's in the, like they do have an image, but then they describe what's in the image. So it's a little hard to disentangle. So it's really hard to say how the models break down over specialty. That's still something that we really need to figure out over the long run. The other reality here is that this is not how doctors make decisions, right? Doctors don't get all the facts, everything they absolutely need, and then they get a multiple choice list and they make a decision. That's just not how medicine works. Medicine is a little bit in these complex cases is a detective game, and you can always collect more clues. So one of the questions doctors have to answer is, do we treat this now, or do we collect more information? Should we send the patient out for this test or this test? And do we think that's necessary? Can we be confident to diagnosis now? That is much more how people present, and that's not in any way how these models are being evaluated. So how do we build benchmarks and evaluation sets, and how do we score models at doing that sort of thing, right? So one way we're thinking about in my group is there's two things we care about. One is, did the model get the right answer? But also, did the model get that right answer in an efficient way, right? So let's say a patient comes in and the patient says, you know, I have this issue. You could imagine that you have enough information to make a diagnosis, or you can send that patient to a specialist or for a follow-up test or all manner of things. The model is always happy to send the patient out to collect more information, you know, to have more exams, but that's not free, both in terms of cost or the burden on the patient or the time to get to treatment. So how do we balance those types of things? There is no evaluation models in this way, right? I think also very critical is I am not advocating that these models become doctors, and I don't think that's going to happen anytime soon. So it's not so much what the model knows, what the model does. It's all about how we make doctors do a better job and how we help doctors do a better job. And again, that's not how these models are being evaluated. So one of the big focuses in my group is not, did the model make the right decision, but did the model explain that decision with the right information that allowed a doctor to make the right decision? And that's what I care much more about. If you tell me, let's think about it this way. If a doctor doesn't know the answer and they turn to a model like this, an AI, and the AI gives them a diagnosis, I don't know any doctor who will just take that diagnosis and run with it, right? The whole reason the doctor asked is they don't know. So if the model is saying this is the diagnosis, the doctor wants to know, why? How did you come up with that? What other things did you rule out? All these kinds of decisions. These models have not been evaluated in that way. And so that's something that we're really interested in evaluating, how these models can help doctors make the right decisions, how they can help doctors narrow down their decision, how they can collect more information. And that's stuff that we are only starting to investigate in my group. Okay, so let me move on. There's a lot of other questions here, but I will get to some of them. The questions that now we're starting to think about is, well, what do we want to use these models for? Because there is not one use in medicine, and therefore there's not one way to evaluate these models in medicine. Depending on how we will use them is going to vary how we're going to evaluate them. Okay, so I think one thing that I have learned kind of immediately is the amount of opportunity that exists in this space. So I did this paper that came out about a year ago, and the paper was, I think, a really simple paper on a really simple idea. Who gives better answers to patient questions, doctors or AI chatbots? Okay. Now, obviously, that's a complex question. It depends on the types of doctors. It depends on the types of patients, the questions, all this sort of thing. So we, again, very simple paper. We took a series of questions that we were able to get online because it was really easy to get. And we got a series of answers from doctors online as well. And we just simply compared those answers to answers from chatbots. And what we found was that the chatbots gave much better answers in terms of both the quality of the answer and also, very interestingly, the empathy that was perceived in the answer. If you look at the types of actual answers that were given, this is not really a surprise. So I'll just pick one from here. The last one on the slide is someone said, basically the question was, I'm worried I got a bleach in my eye, it hurts. What should I be worried about? And the second column is the physician response. Sounds like you'll be fine. You should flush the eye out, call the poison control, right? The chatbot answer, you can see why it received a higher empathy score, right? I'm sorry to hear you got bleach in your eye. It's important to rinse the eye as soon as possible. If you have not already, it's a clearly, you can see why it got a higher empathy score. And it's also longer, contains more detailed information. So I'm bringing this study because the lesson I learned from here was not that chatbots could do a good job. But when this study came out, and you would ask me at the time, I would have said, yeah, this was really interesting. It's the first step in many studies over the next 5 years that will demonstrate the capabilities here. And maybe one day we will have doctor-assisted, we will have AI assisting doctors in answering medical questions. Before the study even came out, Epic and Microsoft announced a partnership with a bunch of medical institutions to pilot this exact kind of system. And so what surprised me is how fast things can move in medicine here and how much there is a demand. That a lot of the things we're talking about here are not necessarily maybe in a couple of years, maybe one day, but there really is a potential and a hunger for building these things and using them in the near future. So I'm not necessarily saying that all this technology will be ready in the near future, but there is a huge opportunity to affect medical care in the near term in addition to the long term. Okay, so what are those opportunities? And now we're going to get into some of the details here about actually what can we do and how is this going to impact patient care? And I'll just give a couple of examples as we go through. So I'll start by telling you about some basic opportunities, both some of the classic things that we've worked on, but also new opportunities that are emerging. Okay, so the first one is something I hinted at or talked about at the beginning, which is doing better at the things that we are already doing. There are so many applications where we need to pull information out of medical records or answer questions about medical records. And the bottleneck for these types of applications is simply the data you need and the staff that you need to get it done. And it used to be the case that someone would come to my group and say, well, we have a study that we want to pull out all references to this types of disease. And I'd be like, great, we can do that. We're going to need to label some data. We're going to need some data scientists. We're going to need some AI engineers. And this will take 2 or 3 years. And, okay. And now ChatGPT and these types of models, they don't solve the problem as well, but they give you a solution that's immediate. And so it dramatically lowers the cost to operating in this space. And that is really transformational. And now, simply put, a lot of the people contact me about partnering on a grant or partnering on a project. I say, you don't need me. Like I don't need to be here. There's a much cheaper solution, and you can do this without me. And I think that's really going to be transformational for medicine. So even though we've been doing that type of thing for a while, I think it is not to be overlooked. Obviously, I think there's going to be a lot of tremendous opportunities in medical care. There's going to be opportunities to help doctors make decisions like diagnosis and treatment decisions. I've already hinted at some of the problems here with the current way of evaluating that. USMLE is not what the real world looks like. So how do we actually help doctors with real patients deal with real issues in the types of questions they'll have questions about, or the types of patients they'll have questions about? How do we actually hook up these systems to the medical record so that it has access to that information? How do we hook them up to the latest literature so that for evolving conditions where we have new information, the systems can make use of it? How do we hook it up to guidelines, that we're putting out on the latest and best way to do care? There's a lot of questions here. And of course, the answers here are going to vary by discipline of medicine. I don't think the way we do this for radiology is going to work for the way we do it for, pediatrics necessarily. I think there's a lot of potential here to improve patient communication. So I think you saw some of that in the examples I had about responding to patient questions, where language models are really good at giving basic information. So the way I often think about it is sometimes when you go in the doctor's office and you have a pretty standard condition, they hand you a pamphlet, right? They say, go take this medicine. This is what your condition's called. Here's a pamphlet that tells you all the details and answers all the questions. Let me know if you have any questions. We cannot make pamphlets for everything. So a lot of times you go to the doctor and there's not a pamphlet and the doctor has to answer your questions, and there's a limit to what can be answered in a session. There's a limit to the details doctors can provide. These models can help fill in those details, right? So we don't have to write a pamphlet for every case, but we really could have the doctor say, well, you should take this medication, and I'm going to actually, rather than give you a pamphlet, this system can write out very specific detailed instructions for you based on the specific medical condition you have and what I'm going to be suggesting. And then, of course, there's lots of research questions that these technologies can enable. There's a lot of technical questions that we need to solve in order to make this happen. So, for example, one is uncertainty. These models right now are really bad at saying, I don't know. But I don't know is really, really important in medicine, because many times you have a patient and you need to say, I don't know, what do I need to go do to get the answer? And whether that's looking something up, or that's ordering a test, or that's doing a consult, there are a lot of ways that you pivot from I don't know. These models are not good at that. Historically, we've talked about things like probabilities and confidence intervals and all of that. Those don't really apply in the same way to these models. And so it's really hard to say how that's going to work here. Differential diagnosis in clinical diagnosis is the name of the game. How do these models help with that, right? That is a potential place where doctors really could use assistance. Like, what is the best test to do? And the nice thing is the models can bring in other information, right? The models have access potentially to things like cost, discomfort, availability. There's a lot of factors, some of which are not available to doctors. In theory, the models might have access to that and help doctors, guide doctors to better decisions. That's a really interesting set of questions. We don't know the answer to that. Let me skip past that. Consumer facing is a really big question I have. So this is outside of the doctor's office, but it's really important to consider. So I have heard many, many people say correctly, you should not be asking medical questions to ChatGPT, right? It is not giving good medical advice necessarily. It's especially convincing when it gives advice. And so it can be very misleading in ways you don't know. And I think all that is true. I will also say we said all those same things about Google, right? I've heard many doctors say, don't just go Google things and read whatever the response is. I think a lot of doctors have patients that come in and say, well, I read this online, and the doctor's like, well, don't believe everything you read online. And yet people use Google for surface information. So we do need to be thinking about how to provide better care information, better health information through these models, because people are going to use them. You can put all the disclaimers you want on them, people are going to use them. I'll give an example from outside of healthcare. I don't want to scare anyone, but taxes are due in like 3 weeks. And TurboTax and H&R Block both piloted AI-assisted question answering bots this year. You can go try it out if you have an account on either one of those platforms, where you can type in a question, a tax question, and they will generate an answer. And it says, this is an automatically generated answer. Do not rely on it for tax advice. We're not saying it's correct. All that said, you can ask it tax questions and it gives bad information. And I'm sure that people infer that if TurboTax is a chatbot that's giving information, it's probably correct, right? So people are going to rely on these systems to answer questions. And how do we build better systems, or at least build better interfaces that people understand the perils of doing that? I'll say one more thing because I see questions from GPT-4 about taxes. So if you watch the GPT-4 keynote when it went live, they had a tax question in there and showed the GPT-4 can answer tax questions, and how impressive is that? And my colleague here at Hopkins watched it and said, that looks really familiar. And it turns out the question they used was from a data set he built on how to evaluate chatbots answering tax questions. And then he went and looked, and actually GPT-4 got the question wrong. And so it was really interesting because even their highlighting of the case of, look what our system can do, if you actually looked at it, it was a wrong answer. And so we need to be really careful. Obviously, sometimes they give the right answer, but not always. Sorry, hang on, I lost my window here. Okay. I think another question I get a lot is medical education. And this is a big, big question in a number of ways. First of all, how can we use these models to improve medical education, right? These models clearly know stuff about medicine. How can we use them in training doctors? And that might mean using these models as study guides, helping them study. It might be using them as kind of synthetic patients, right? So we can actually have doctors kind of practice patient interactions and making diagnoses, interacting with these. But there's a lot of ways to integrate language models into medical education. One thing I heard from people who teach is we don't do a very good job of giving students feedback on the work they do, simply because there's a limited instruction. So can these models actually give trainees feedback on how they take notes and things like that? There's also a big question of what we should be teaching doctors now. So if you look at math education, we stopped teaching people how to use slide rulers, right? So we just realized that they weren't going to be used in the future. We have computers now, we have calculators. You don't need that kind of technology anymore. I have, maybe it's over there on the bookshelf, a book of logarithms published in the late 1890s. I have as a novelty because we don't need those books anymore. What are the things that we teach doctors now that we should stop teaching them because they just won't need it in the future because they will have AI technology to help them? I don't know. Similarly, we fully expect that AI is going to be part of the medical workforce, in that doctors are going to be using AI systems. They already do. That's going to increase. When we teach medical students now, what we're really teaching them is how they're going to practice medicine post-residency, post-fellowship, so years down the road, right? What should we be teaching about AI now that won't be out of date in a year or 2 or 3 years? Very challenging. I don't know the answer to that, but we need to figure that out because we are educating medical students to do these types of things. There are many other challenges that we have here. So how do we evaluate these systems? I've talked about that a lot, but we can't simply run a clinical trial every time we want to build a new system. We need another way of doing these evaluations. How do we evaluate them on realistic clinical data, not just things found in medical articles? The regulatory space here is a huge issue, and it's very much an unknown in a lot of ways. How should we be regulating medical AI? So very simply, if I build a new tool that says this tool is really good at doing whatever, something in medicine, what kind of evaluations of that tool should we do before it's put into practice? And if I update that tool in a week, which is good, updating tools is good, right? My phone updates all the time, and that's a really good thing. What kind of new evaluation should we be regularly doing about those updates? So imagine thinking about vaccines, right? Think about all the work we do into evaluating the new COVID vaccine, the new COVID booster. Imagine if we had a new booster every week. How are we supposed to evaluate that? How are we supposed to keep up with that? There are a lot of other issues here talking about the regulatory space, but they really are enormous, and it's happening really quickly. I absolutely need to talk about bias and fairness at scale. This is a huge, huge problem. A lot of the evaluation right now in the AI space is on individual cases. Did the model do the right thing for this person, or in this case, or for this example? The problem is in medicine, very often when you look at an individual case, the decision seems totally reasonable. So think about studies on disparate prescriptions for pain relief based on the racial background of the individual, right? We know this is true. And that in general, whites have a higher rate of getting medication for pain than blacks. The problem is, if you look at individual cases, they're pretty reasonable, right? It's rare that we see a case where a doctor egregiously withholds or prescribes medication. But when you look in an aggregate population, you see big differences. How do we evaluate these types of technologies when individual decisions might all look reasonable, but in the aggregate, they cause problems? And then critical in medical care is accountability and transparency. I'll give one example. Whenever I talk about the study about answering patient questions with AI, I get two responses. One is doctors who ask, is this available? Can I use it now? Because my inbox is overwhelmed with messages. I cannot keep up. I really need help. If you're telling me there's a tool that does a pretty good job, I'll take it right now. And other doctors who get angry with me that I would even suggest such a thing, and they want no part of it. The reason they're angry, in part, is because when a doctor sends a message to a patient, they're taking responsibility for that message. And if an AI system generates 4 paragraphs and the doctor says this looks fine and they send it, a doctor is now liable for everything that went out in that message. And if the machine did something wrong, had the wrong dose of a medication in there or missed something, the doctor is liable. That's pretty substantial amount of liability to take on, especially when these systems are really good at generating a lot of very convincing text that people just cannot evaluate. So there's a lot of issues here that we need to go through and that we're struggling with. I talked about evaluation. I think we need to be thinking specifically about how these models are going to be used. And that means working with the medical system. So whenever I talk to people on AI and they're saying, well, this is going to be good for medicine, I always ask them, well, like who? Because medicine is not a monolith, right? We have providers, and that's not a monolith either. There are doctors, there are nurses, there are different types of doctors, there are different types of nurses, there are other medical workers. They all have slightly different needs, goals, ways they work. You might do something that the doctors love that the nurses hate, right? So you have to be careful there. The patients, and I like it when patients and doctors are aligned, but they're not always aligned. And sometimes systems are better for one and worse for the other. But patients, of course, are important stakeholders, and we need to be thinking of them in the process. And then hospital systems, right? They're another stakeholder. How is this technology going to affect the hospital system? And I think many people who are doctors can think of cases where their needs and patient needs and hospital administrator needs were not aligned. And technology is going to change that landscape. You need to be aware of who it's changing it for and how. Not on the slide, but I'll throw in insurance companies, right? Insurance companies have already been in the news for using AI in various ways, and it's not always to the benefit of patients or the benefit of doctors. One of my favorite examples is doctors using it on insurance companies. So one of the uses of ChatGPT that a lot of doctors have admitted to is using it to write letters to insurance companies for authorizing procedures, right? Doctors hated writing these letters. ChatGPT is really good at it, so they're happy to generate that. Like, insurance companies care about that. So we can't talk about AI, we can't talk about the health system as a monolith. We have to talk about, well, who in the health system are you affecting and how? I have more examples of that, but I will skip them for the interest of time. Let me just wrap up and then deal with some of these questions. So I'm very curious from the questions on what people here think. As I said, healthcare and medicine is a very diverse space, and there are a lot of different kinds of systems that we could build. I have focused today on language models and text systems because those are the things I work on, and that things getting a lot of excitement, but they are by no means the only type of AI. So just like you wouldn't expect the system that drives your Tesla to be the same type of system that makes financial decisions, to be the same type of system that is ChatGPT, you're not talking about the same types of system in medical care. And so while I focus on one type of AI, there are many, many types of AI. Some of these issues apply 100% in those cases as well, but those different technologies pose different challenges and opportunities as well. All right, I'm going to take some of your questions. I assume everyone is giving me a standing ovation. I just can't see you, so I appreciate it. So let me start, and I'm not going to get to all these, but I was kind of keeping an eye on them, and let's see if I can hit some points that I did not already hit in my talk. I think one question is on the type of technology we're using. There is a push in the industry towards accuracy, a push to build systems that are better at doing the things we want them to do. And that makes sense in a lot of ways. But and we build, therefore, the technology like the core neural networks around those goals. That doesn't make sense for every case, right? So in medicine, oftentimes what we care about more is the process, or what kind of information was considered, or how it was considered. And these models are not necessarily good at that. And so I think that by exploring medical cases, we will introduce new requirements onto the development of AI that might disfavor the kinds of AI that industry is really pushing on heavily, and think on other types of applications. In terms of, let's see what else. Sorry, there's a lot of questions here. So what do I want to talk about? Hang on. So let's talk about patience for a moment. I think that there's a lot of opportunity here to empower patients. I will give one example. So this is something my group is starting to work on. So 2 years ago, open notes became the law of the land. If you're not familiar with this, patients now are supposed to have easy access to their medical record. So under HIPAA, what was kind of new about HIPAA is you could request your medical record, but many of you might remember what that meant was you can go to a room in the basement of the hospital, fill out a form, and in 6 to 8 weeks, someone would send you an envelope. And now there's a requirement for essentially instant access. So I go to the doctor, and a couple hours later, I get an email that said, the notes from your visit are now available online. So that has changed access to patient information for the patients, but it doesn't mean that information is easy to understand or accessible. How do we use these types of technologies to help patients understand their medical record, right? So I just got a bunch of lab results done. I got the lab results. I looked at them. They were all totally meaningless to me, right? So I was sitting there Googling, like, what does this mean? What is a normal range here? For lab results, that's actually not so hard to do because they're all standard tests and you can just look them up. And a lot of actually labs will now put it into the notes and they'll say like, here's a standard range, this is what this is testing for. But if you think of the wide range of things that we do in medicine, how much that's not accessible to the patient, language models have the ability to bridge that gap, potentially looking at medical records and helping patients understand. So there's a lot of opportunity here for patient engagement that we couldn't have before. I think something else that we need to be careful about is we often think about evaluating these models on their own and not as part of a human process. And one thing that people in AI, I think, really underestimate is how complex humans are. So I will give an example. There's a study done that I really like where what they did, this is not in medicine, what they did is they gave humans two systems. One system explained the decisions of the system and the other one did not. And they asked people to correct the mistakes. So here is a decision that was made, fix it if it's wrong. And the idea was that if the system explained its answer, people could see where that explanation was faulty and therefore do a better job of correcting the system. What they found was the opposite. The system that explained its behavior, humans did a worse job of correcting it. The reason is because when no information was provided about why the system did what it did, humans had to themselves go and look, right? And they were more careful when they went and looked. When they were given an explanation, humans verified and said, oh, well, this explanation seems about right. I think the system knows what it's doing, and they went along with it. We need to be very, very careful about how humans use AI in medicine, because it's very easy to imagine a system that is making recommendations, that is explaining those recommendations in detail, and because they sound good or they sound mostly correct, doctors will approve them because doctors are just humans. And that means that the system is not being checked by doctors and it's actually just doing whatever it does. And that's going to cause obvious problems. So how do we actually build systems that actually help doctors make better decisions? And the only way, unfortunately, I'm going to do this is to test it with doctors, because humans are complicated and the littlest things that you don't anticipate change human behavior and change thinking. So I think that's a huge issue for AI researchers about how to engage with medicine and doctors and nurses and patients and all the stakeholders to make better decisions. I think I have to wrap up, so I'll say one more thing. I think everyone understands here how complicated medicine is. And when people talk about opportunities in medicine, it really needs to be done in partnership with all these stakeholders, because they are often aware of opportunities that we just don't know about. So I learned this many years ago when I was given an example of talking to some clinic, and they said, well, what would really be helpful is when a patient is supposed to come in for follow-up care, that they come in for follow-up care. And I'm like, well, what do you mean by that? I'm like, well, oftentimes a doctor says, please come back and see me in 6 months. And they write in the record, patient should follow up in 6 months, but the patient doesn't. I've been that patient before. You forget, whatever. But they had no mechanism to do this. And it's not a hard problem, right? You can just imagine that you make a note in the calendar, in 6 months, call this patient and schedule them for a follow-up appointment. They had no way of doing that because it was just locked in the medical record and no one was going through the medical record and seeing it. Now, that's a pretty easy problem to solve technologically, and it's really low-hanging fruit, but that's not necessarily what we're thinking about when we're AI researchers. So speaking to people actually in medicine helps reveal kind of these really interesting opportunities where we might actually be able to do something technologically. Anyway, so that's been a little bit of my experience. I know I didn't get to all the questions. I will, someone did ask for citations. So they're on, oh no, they're not on my website, sorry. The citations I mentioned are on my website, but I can say if you go to archive, if you know it, arxiv.org, and you search for my name, you'll see there's a couple of new papers there. If you want to email me for specific references, I'm happy to provide them. I really appreciate your time and attention today.
Thank you, Mark. And for those of you who are still with us, this will be posted on our website within the next few weeks. Thank you so much for joining us here at the Hopkins AITC.
Thank you for having me.